So number 13 says find the component form and magnitude of vector AB with initial points negative 4.3, negative 0.9, and terminal point negative 2.8, 0.2. So remember how we find the component form is we take B minus A. So negative 2.8 minus a negative 4.3. So that ends up being 1.5. And then we do it for the y component as well, which is 0.2 minus a negative 0.9. And so that's going to be 1.1. And so my answer is either A or C. Now I need to find the magnitude. And remember how we found the magnitude is we took our components, squared them, added them, and took the square root. So I would take the square root of 1.5 squared plus 1.1 squared. That ends up being 1.86. So the correct answer is C. Number 14, the position of one airplane is represented by 12, 2, 3.7, and the second airplane is represented by negative 1, 7, 5.2. Determine the distance between the planes if one unit represents 1 mile. So first I have to find the resultant vector, so I just simply add them. So 12 plus negative 1 is 11, 2 plus 7 is 9, and 3.7 plus 5.2 is 8.9. Now to find the distance or magnitude between them, let's square them all and add them together, then take the square root of that. And when I do that, I get 16.769, which rounds to approximately 16.8 miles. Number 15, a constant force of 22 newtons is being applied at a constant angle of 48 degrees on an object at the same time that a constant force of 54 newtons at a constant angle of 135 degrees are on it. So what is the magnitude and direction of the resultant force? So essentially what I need to do is I need to find my two vectors. So the first vector is going to be the magnitude, which is 22 cosine of 48 degrees, comma 22 sine of 48 degrees. And so what I do is I get 22 cosine 48, so that would be 14.7, and 22 sine of 48 is going to be 16.3. That's my first vector. Now I find my second vector, which is 54 cosine of 135 degrees, and then 54 sine of 135 degrees. And so I get 54 cosine of 135, that would be negative 38.2, and 54 sine of 135 is going to be 38.2. Okay, so now I need to take my two vectors and I add them together. So this one plus this one to find my resultant vector, which is 14.7 plus a negative 38.2 is going to be negative 23.5, negative 23.5. And then my y would be 16.3 plus 38.2, which is 54.5. Now if I want to find the magnitude, I square both of those numbers and add them up. And take the square root of that. And I get 59.4. So without even having to find the angle, it's going to be D. If I wanted to find the angle, remember it's the cosine, or excuse me, tangent of B over A. Tangent theta is B over A, which I could check my answer. 54.5 divided by and I'd get a negative, but 66.7 degrees. So that is correct as well. All right. Number 16, find the dot product, then determine if the vectors are orthogonal or not. So remember how we find dot product of these two is we simply take 8 times negative 4 plus 3 times negative 6. So 8 times negative 4 is negative 32, plus, and then 3 times negative 6 is negative 18, which would be negative 50. Are those orthogonal? It is not, because it's not equal to 0. So A is the correct answer. Number 17, an airplane is traveling due east with a velocity of 620 miles per hour. The wind blows at 45 miles per hour at an angle of 30 degrees north of east. Determine the velocity of the airplane's flight. So again, I'll write two vectors. So first one, due east with a velocity of 60 miles per hour. So if I'm going directly east, that's going to be 0 degrees, correct? So it's going to be 620 cosine of 0, and then 620 sine of 0 degrees. And so we find that to be 620, 0 is that vector. Then the next one is 45 miles per hour, 30 degrees north of east. So that's, again, 30 degrees up from here. So I can use an angle of 30 degrees. And so that's going to be 45 cosine 30 degrees, 45 sine 30 degrees. And so I would get this vector would be 38.97. So we'll just say 39. And then 45 sine of 30 degrees is 22.5. So now what I have to do is add my vectors together. So 620 plus 39 would be 659, and 0 plus 22.5 is 22.5. Remember, if I'm finding the magnitude, I square those numbers and add them up, take the square root. So it's the square root of 659 squared plus 22.5 squared, and I find it to be 659.4, pretty close to 659.7 miles per hour. So number 18 has us find the volume of the parallelepiped with adjacent sides U, V, and W. So remember, to find that, what we did is we took the matrix that had all three vectors in it. And in the sake of saving space, what we did is we took this and multiplied it by the determinant of that matrix right there. So 1 times negative 5 times negative 8 is positive 40, minus 1 times negative 4 is negative 4. So 40 minus negative 4 would be 44. That's my first part. Then I had to subtract 2 times the determinant of this matrix. So 2 times, and then 6 times negative 8 would be negative 48, minus 1 times 6, which is 6, so that would be negative 54. And finally, the last one was 2, adding 2 times this matrix right here, the determinant. So 6 times negative 4 would be negative 24, minus, and then 6 times 5 would be negative 30, and so I'd get 6 for that one. Okay, so now it's just 1 times 44, which is 44, minus 2 times negative 54, plus 2 times 6. When I add up all that, I get 164 units cubed. Number 13, Jared pushes a box up a ramp with a constant force of 55.2 newtons at a constant angle of 22 degrees. Find the work done in joules to move the box 4 meters. So the easiest way to do this is to say that our work is actually the force times the vector in which it moves, which is 4 meters in the x direction. So what I would do is to find the force in which he pushes, it's going to be 55.2 newtons times the cosine of 22 degrees, then 55.2 sine of 22 degrees. And so I find that vector to be 51.2 and 20.7. Then I'm going to multiply that by the vector find the dot product between this vector, which is, well, it's 4 meters in the x direction, so it'll be 4, 0. So now all I have to do is find the dot product between those two. So it's going to be 51.2, 20.7, dot 4, 0. So I find that to be 51.2 times 4, which would be 204.8, which is pretty close to 204.7. Again, difference of rounding. So D is the correct answer. And the reason that is because the 20.7 times 0 would be 0, and so your resultant vector would just be 204.8, 0. Square that, take the square root. It's going to be D. Now finally, the last one, question number 20. 3W minus 4V. So first, I need to find 3W. Okay, so 3 times negative 2 is negative 6. 4 times 3 is 12. I have to find 4V, which is going to be 4 times negative 4 is negative 16. 4 times 0 is 0. And now I simply subtract them. So negative 6 minus a negative 16 is positive 10. 12 minus 0 is 12. So my answer then is going to be